So we're going to move into our next unit, which is trigonometry, and we're going to kind of break this up into sort of three parts. One will be review, where we're doing right angle trig, where we have a 90-degree angle. And then we're solving using either Pythagorean theorem or we're using our SOHCAHTOA, which I'll explain to you in a moment. We're going to work with non-right angle triangles. And so now what we do is we talk about something called the sine law and the cosine law. So the nice thing is now we no longer have to have triangles that have a 90-degree angle in them. I could give you any random triangle and make you solve for any random side or angle. So this is where we're heading. So before we head there, we're going to review a little bit of what we already know about trig, which is kind of our right angle trig. So we will always see this little square in here indicating that that's a 90-degree angle. And when that is true, we can use our SOHCAHTOA. And what SOHCAHTOA tells us, for example, the S in SO tells you the sine of this angle is equal to the ratio of whatever the opposite number is to the hypotenuse number. The C in Ka stands for cosine of the angle, equaling the adjacent over hypotenuse side. And the T stands for tangent of the angle as opposite over adjacent. So pretty much what we're doing here is we're getting a ratio of two sides of a triangle and what angle that produces when that ratio is possible. Okay. We will also talk about Pythagorean theorem, which means that the hypotenuse squared is always equal to the side squared. So I'm going to write hypotenuse squared is equal to side squared plus side squared in any order. How will you be able to tell where the hypotenuse is on a triangle? Is you kind of look at the 90-degree. There's kind of a point right there. Wherever that arrow would point, this would be my hypotenuse of the triangle. Okay. So we need to know our SOHCAHTOA ratio. So SOHCAHTOA ratios, which are the ones above. In case you forget the ratios, try to remember SOHCAHTOA. We will need Pythagorean theorem, and we will also need one of the rules we've already learned, which is kind of our triangle rule, that the angles in a triangle add up to 180. Now, another thing we have to recognize is that our calculator always has to be in degree mode. So if you have a TI-83 or a TI-84 or TI-84 plus or this color edition, you're going to go to the button that says mode. And when you hit mode, it will take you to a screen. And on that screen, we're going to use our arrows going down. We're going to use the down arrow twice. And then it will take us to the word radian or degree. You want to move your cursor to the word degree. And then when you move the cursor to the word degree, we're just going to hit enter after that. And that will turn our calculator into radian mode. So once you do those steps, you can hit second mode to get out of this settings window. So again, we need to make sure our calculator is in degree mode. If you ever go to grade 12, you'll learn about something called radians, which is another way we can measure angles. Now, for all of these review practice questions, even though the question doesn't mention it, all triangles are right angled. Okay, in a given question, if they make a picture and it looks like a 90-degree angle, we can't assume anything. So if they forget to show us that little block, we have to be using trig that is involved on non-right angle triangles. But the ones shown below are all right angle. Okay, so on this triangle, I'm going to draw a right angle triangle. And it's a 90-degree triangle. I'm going to put the opposite of the triangle, and the adjacent is 5. And the hypotenuse is, we want to find the hypotenuse to the nearest 10th. Now, when they talk about an opposite side and an adjacent side, they need to be looking from a specific viewpoint. So I'm going to assume, here's my angle. I'm going to call it X. So the adjacent side of this angle is the one that's kind of beside it. The one that is sort of directly across the X would be my opposite side. And my hypotenuse is always the one that is directly across from the 90-degree symbol. So there's my labeling of the triangle. That should be a review for you guys. I'm just going to put the variables in, and I'm going to put an X in here to know that that was my viewpoint. So the adjacent side is 5. The opposite side is 10. And we're looking for the hypotenuse, which I'm going to call H. So Pythagorean theorem says hypotenuse squared is equal to side 1 squared plus side 2 squared. So my hypotenuse H squared is equal to 10 squared plus 5 squared. So on my calculator, I'm going to work out 10 squared, which is 100. I'm going to work out 5 squared, which is 25, and I'm going to add them together, and I get 125. Now, when I solve for H, I'm going to square root both sides. And normally we would have a plus or minus in there, but here we're only taking the square root of 125 because my hypotenuse is always positive. And when I take the square root of 125, I get 11.180338989. And we want to round it to the nearest 10th, which means I want to kind of stop my number there. I look at the decimal beside, I look at the number beside the 10th. That 8 is bigger than or equal to 5, so my rounded answer is that the hypotenuse is 11.2, and then the units of this answer are centimeters. Let's look at another example. I give you a 90-degree triangle. I will show my 90 degree in there. One of the angles is 30 degrees, so I'm going to put it there. And the side adjacent to the angle, so that one would be opposite. This one would be hypotenuse. And so this leftover side is my adjacent. And the value of the adjacent is 5. And I'm looking for the opposite, which I'm going to call O. So now, when I look at my triangle, I have my angle, I'm looking for my opposite, and I have a value in my adjacent. So I have an angle, I have my adjacent, and I have my opposite. So in my SOHCAHTOA, I'm going to try to figure out which ratio I want to use. And you can see here that tan has the opposite and adjacent side in its formula. So what we're going to do is we're going to write tan of my angle. So when I have a 30-degree triangle, the tan of that 30 degrees is equal to the opposite side divided by the adjacent side. And I want to solve for O, so I'm going to multiply both sides by 5. So 5 times tan of 30 is equal to my opposite side. I'm just going to write OPP so it doesn't look like 0. And so, therefore, my opposite side, if I do that on the calculator, 5 times tan 30 is 2.886751,346. So on your calculator, you're going to hit 5. You're going to hit the times button. You're going to hit the tan button. And then you're going to hit the value 30 and then hit enter. So be careful you're entering that correctly. We want to stop our answer at the nearest 10th. So I look at the number beside it. That 8 rounds this 8 to a 9. So my answer for the opposite side is 2.9 centimeters long. Now let's look at another example. So the angle is 30 degrees. Now I'm going to just draw my triangle in reverse, just to show you it doesn't matter which way you draw your triangle. Okay, so I'm going to throw in my 30 degrees. My side opposite to the angle is here, because it's the one directly across. My hypotenuse is what I'm looking for. And I don't even need to throw the adjacent in on my triangle, because the question is asking specifically, find the hypotenuse. So I want the hypotenuse involved in my question. I want the 30 degrees involved, and then the opposite side, they give me a value for it, and that value is 2.5. So I want to look for the ratio that has my opposite, my hypotenuse, and my angle. So when I write down my SOHCAHTOA, I want to look for which one has opposite and hypotenuse, which is my sine ratio. So let's write that down. Sine of 30 degrees is equal to my opposite side over my hypotenuse, and I want to solve for h. So in order to do that, the first thing I'm going to do is multiply both sides by h. So I get h times sine 30 is equal to 2.5. And then I want to ask myself, how am I going to get the h by itself? Divide by sine of 30, divide by sine of 30, and then I literally get my h isolated. h is equal to 2.5 divided by sine 30. I'm just going to purposely put a bracket in there just so we don't make any bad errors. And I get the answer of 5 exactly. And so rounded to the nearest tenth would be 5.0 centimeters. Okay, let's try one last example. The opposite side of a triangle is 10 and the adjacent is 5. Find the angle. This time I'm just going to randomly throw the angle up here to show you it doesn't matter. So that angle is there. The opposite side of that triangle is down here because it's directly across from it. The hypotenuse is directly across from the little square, and the adjacent is the side that's left over, and the adjacent is 5. So I'm interested in the angle. I have a number for opposite and adjacent. When I write my SOHCAHTOA down, I want to figure out which information do I have. I have opposite and adjacent, so I'm using my tangent ratio again. So tangent of my angle, x, is equal to my opposite over my adjacent. Now this one's a little bit tricky because this time I want to get rid of the tan part of the expression. But because tan's a function, what I'm going to do is I'm going to do x is equal to sort of the undoing of the tan function, which is the tan minus 1 function, tan inverse of 10 over 5. So on my calculator, I'm going to hit second tan, and then I'm going to hit 10 divided by 5 in the bracket and hit enter. So second tan, it automatically starts a bracket for you, 10 divided by 5, close my bracket up and hit enter. I get 63.434948882, and I want to round to the nearest whole number because angles usually to the nearest whole number. I look at the decimal beside the number I want to round. It's a 4, so that answer just stays 63 degrees. Now, what we're going to do, that was a review of our right angle trig. This is stuff you should already know, but you may need to review it, and you can talk to your individual teacher to support you with that or get you additional worksheets if you require. Kind of the goals of the course are to work with non-right angle triangles. So as much as we love working with right angle, we want to know how do we deal with triangles that are not 90-degree triangles. But sometimes in order to work with these triangles, you still need to be able to work with the 90-degree triangles. Now, we can't use sine, cosine, or tangent ratios, the SOHCAHTOA stuff, and we can't use Pythagorean theorem because we don't have a right angle. So now we're going to learn two properties. One of them is called the law of sines, and the other one is called the law of cosines. So in order to do that first, we first need to focus on how do we label a triangle, okay? So what we do to label a triangle, we sort of have three vertice points. I'm going to call one of the vertices A and highlight it red. I'm going to call one of the corner points or vertices B, label it B and highlight it pink. And one of the vertices C, and I'm going to highlight that yellow. Now what we do is the side that is opposite to the angle A, what we do is we use lowercase letters to label it lowercase a. So angle capital A associates with lowercase a. Angle B, capital B, associates with lowercase b. So the one opposite to your B side is lowercase b. The one opposite to your C side is lowercase c. So capital C associates with lowercase c, capital A associates with lowercase a, and capital B associates with lowercase b. We put the angles as the capital letters and then the sides opposite to those angles as lowercase letters, okay? So it doesn't matter what you label them, but often in textbooks they'll label the uppercase letters with capital of a letter and they'll label the sides with lowercase letters. So let's look at this example here. They give me an angle A and a 7 for lowercase a. So I'm going to take one of my vertices, label it A. I'm going to label it in red here just because I did that before. So angle A is 20 degrees. The side opposite, they label it with lowercase a and it's 7. B, they label B as 100 degrees. And the side opposite to it, they give it a number 18. So capital B is my angle 100. The side opposite is 18. And then capital C, they label it to be 60 degrees. And the side opposite to that is 10 centimeters. So, and I can see here there's a little typo. That should be a 10 centimeters. And I'm just going to come back and re-highlight A in red for you here just because it matches my diagram. Okay, so be careful on the question. There's a little bit of a typo there. That should be C is equal to 10 centimeters. Now, just more terminology for you. An obtuse triangle has an angle greater than 90 degrees in its triangle. And an acute triangle or an acute angle is one where there's a less than 90 degree involved. So for example, this angle here would be an obtuse angle. And this would be an obtuse triangle because the angle involved, one of them is bigger than 90 degrees. So let's try these two examples that are presented below. Now, when you draw your triangles out, you can draw them however you want, as long as there's no 90 degree involved. You don't have to use a protractor, ruler, anything like that. Just draw a random triangle. It does not have to be drawn to scale. We're going to label the following angles. So capital A, I'm going to put at the bottom left vertex, and this angle is 25 degrees. So do they give me a little a? Yes, they do. The side opposite to that angle is 4 centimeters. And then I'm going to label that A and lowercase a. Now angle C is 25 degrees, so I'm going to draw one of my smaller angles 25 degrees. I'm going to label that angle capital C, so I'm going to label that to the bottom right vertex. And the side opposite to that is 4 centimeters, which is my lowercase c. And capital B is 130 degrees, so the larger of my angles is going to be labeled 130. This is capital B. The side opposite of it is 12 centimeters. Now, because this side and this side are the same, I can use a little line here to show that these are the same. I have two sides the same. This is called an isosceles triangle. We've seen that before. You see that the two sides are the same, but also those two bottom angles are the same. Okay, Now again, in some of the triangles, you don't always need to label it ABC. If it doesn't help, you can put the numbers in, but just be aware the A and the little a have to go opposite one another. So in this example, I'm going to start with my largest degree, which is B. Out of my 3 corner vertices, I want to see which one has the largest angle. I'm going to label the top vertice 105 degrees, labeled with a capital B. The side opposite of that is 20 centimeters. They give me that in the question. One angle is 30 degrees. That's A. I'm going to try to find the smallest looking angle, call it capital A. The side opposite to that they label as 10, and I'm going to use centimeters. And capital C I'm going to use as the bottom right vertex. That looks like the most medium angle there. That's going to be 45 degrees, and the side opposite of that is 14 centimeters. So now we're ready to investigate the law of sines. So what the law of sines tells us is that there's a very specific relationship to it, which is kind of down here. I'm going to label it sine law. You don't need to derive the sine law, but kind of just know where it comes from. So here I sort of have a triangle that's a non-90 degree triangle, and I take this vertical line here to break this triangle up into 2 90 degree triangles. So you'll notice that there's a little 90 square in there because I purposely break it up to be 90 degrees, and if that's 90, this other side also has to be 90 because of the straight line rule. So what I'm going to do is I'm going to take the triangle on the left, and I'm going to do the sine of the triangle. So there's my angle A, H is the opposite, and C is the hypotenuse. So I'm going to say sine of angle A is equal to my opposite over my hypotenuse, which is C. And what I do is multiply both sides by C, so C sine A is equal to H. Now I'm going to do the exact same thing on the right-hand side. I'm going to take sine of my angle C, it's equal to my opposite, which is my H again, over my hypotenuse, which is lowercase a, and I'm going to multiply both sides by A, sine C is equal to H. So what I do now is I sort of use a transitive property. This expression is H, this expression is H. So I can take this C sine A and make it equal to A sine C. So that's exactly what I'm going to do. So I'm going to go C sine of capital A is equal to A sine of capital C. That's through the transitive property. And then I'm just going to do a little bit of a division. So I'm going to divide the right-hand side by A. So on my left-hand side, I'm left with C over A sine capital A equals sine C. And then on the right-hand side, or left-hand side, I'm going to divide both sides by C. So what I'm left with finally is a relationship that says sine capital A over lowercase a, because these C's will cancel out, these A's will, is equal to sine capital C over lowercase c. Now, depending on the way you rearrange it, you could have got the relationship kind of in reverse, where the lowercase a and the lowercase c are on the top, and the sine capital A and sine capital C are on the bottom, respectively. Now, you could do the same thing and get a relationship with A and B. So sine of capital A over lowercase a, sine of capital B over lowercase b. And so essentially you have this thing called the sine law. Now, when you're doing the sine law, there is a formula on your formula sheet. What we're going to do is I'm going to go sine of capital A over lowercase a is equal to sine of capital B over lowercase b equals sine of capital C over lowercase c. I'm going to write that in my question. So it says, use the law of sines to find angle AB for the triangle, to find side C, which is this one, to the nearest hundredth, which is 2 decimal places. So what I want to do is you don't have to worry about the labeling on your triangle. What you do is I take a color, I label my angle and the side opposite with one color, choose another angle and the side opposite with another color, and then 77 degrees with the side opposite as another color. You'll notice I have the full pair for the pink and I have the full pair for the yellow. and those are labeled A and C. So my capital A is given by 77 degrees, and my lowercase a is given by 15 degrees. My capital C is given by 23 degrees, and my opposite side is C. So I'm going to come back and put that in a ratio. So what you want to do is take all the pairs, the angle side pairs, so there will be 3 of them, the A's, the B's, and the C's, and you need to have 3 of them highlighted out of the 4. So if I'm looking at yellow and pink, I need 3 out of those 4 numbers to be able to use sine law. So I'm going to do sine of my angle, which is 77 degrees, over the side that is opposite, which is 15 centimeters or whatever units they decide to use, equals sine of my capital C, which is 23 degrees, over my side opposite, which is little c. Now my goal is to solve for little c. We just need to use algebra. I'm going to multiply both sides by c. So c times sine 77 over 15 is equal to sine of 23. I want to multiply both sides by the 15 to kind of get rid of that off the denominator. So sine 77 times c equals 15 times sine 23. You're seeing I'm using dots to represent multiplication. I want to divide both sides by sine 77. And then I get c isolated. C is equal to 15 times sine 23 divided by sine 77. You carefully put that in your calculator. So 15 times the sine button. It starts a bracket for you. You sub in the 23 and then you end your bracket. Then we have to divide that by sine of 77, close the bracket, and we get 6.015134433. We want to round our answer to the nearest hundredth. So that 5 next to the 1 will round that number up. So this will round to 6.02 centimeters, or whatever units there are. So I'm just going to write units because they didn't provide us the units in the question. We can just assume they're centimeters or something like that. Okay. In the next example, they label my triangle for us. So capital A is 68 and lowercase a is question mark. I'm going to highlight that in yellow again. Okay, my pairs get highlighted. My C pair I'm going to highlight in pink again. So my capital C is 48. My lowercase c is 6. My capital B is question mark. My lowercase b is question mark. So as of right now, I need to find lowercase a, lowercase b, and capital B. So that's solving the triangle. So sometimes instead of saying find all of them, they'll say solve the triangle or find the solution to the triangle. That means solve for all the missing sides and angles. So when I look at the pink, I have 2 out of the 2 values. And when I look at the yellow, I have 1 out of the 2. So if I combine the pink and the yellow highlighting, I have 3 out of the 4 pieces of information. So sine of capital A over lowercase a equals sine c over little c. So let's sub in our values. Sine of 68 over little a, which we don't know, equals sine of 68 over, sine of 48, which is my c value, divided by my lowercase c, which is 6. What we're going to do is we're going to cross multiply. So I'm going to multiply both sides by both denominators. So I'm going to multiply this side by a. So I'm going to get a sine 48 equals, and then I'm going to multiply my other diagonal, which is the 6 with the sine of 68. That's equivalent to my step above where I kind of multiplied both sides by the one denominator and multiplied both sides by the other denominator. I want to isolate for the little a, so I'm going to divide both sides by 40, sine of 48, sine of 48. So I solve that little a is equal to 6 sine 68 divided by sine 48. And let's work that out. 6 sine 68 divided by sine 48. And that gives us an answer of 7.485893646. They want us to round that to the nearest tenth. So that would be 7.5. Let's use centimeters or whatever our units are. We need to find lowercase b now. So to find lowercase b, I'm going to do sine 48 over 6. That's my one pair that I have full information on. And now you'll notice that we don't have the angle B and we don't have the side B. But what we can do is use our 180 rule. We have 2 out of the 3 angles in the triangle. So I'm going to subtract 48 and subtract 68 from 180. And the angle that's left over will be 64 degrees. So that would be my angle capital B. So angle B is equal to 64 degrees because of our triangle rule. So now I write sine of 64, which is my B pair. The side opposite is lowercase b. I cross multiply, so b sine 48 is equal to 6 sine of 64. I want to isolate for lowercase b, so I want to get that side by itself. I'm going to divide both sides by sine 48. So b is equal to 6 sine of 64 divided by sine 48, and that will give me my final answer. And so that value ends up being 7.256680115, and I round that to the nearest tenth, so that 2 gets rounded to a 3. So my side ends up being 7.3 centimeters. Okay, last example. Now this time they make the problem a little bit trickier because they don't draw you a triangle. So I'm going to just draw a random triangle here. And it doesn't matter how you draw it, and it doesn't matter what gets labeled as long as you follow the pairing rules. So they say angle B is 63. I'm going to put it at the bottom left vertex. And they don't give me, or they do give me lowercase b, which is 5.5. So I put it to the side opposite. They give me a lowercase a, so I'm going to throw in my a anywhere. I'm going to just throw it in at the bottom right. And I'm going to use capital A. And they give me the side opposite, which is 4.7. So I know that sine of capital A over lowercase a equals sine of capital B over lowercase b. I sub in all my known information. Sine A over 4.7 equals sine 63 divided by 5.5. And I'm ready to cross multiply again. So 5.5 sine capital A equals 4.7 sine 63. My goal is to solve for A, so I need to divide both sides by 5.5. So sine of A is equal to 4.7 sine 63 over 5.5. Now again, the word sine comes in the way of my A, and sine is a function. So if I need to undo this function, I need to use the function's inverse, which is sine inverse. And on the calculator, the sine inverse is the same as pushing second and then the sine button. So sine of 63 times 4.7 divided by 5.5. So on your calculator, you're going to go second sine. You're going to type in, it's going to start a bracket for you. You're going to type in 4.7 times sine 63 divide by 5.5. and then hit enter, or end your bracket and then hit enter, and you should get the correct answer. So 4.7 times sine 63 divide by 55 is 4.36. I've made a careless error. So 4.7 times sine 63. Divide that answer by 5.5 seconds sine second. So you get A is equal to 49.5882647 degrees, and we round that to the nearest degree, which is 50 degrees. So again, when you're doing it, every time you push the sine bracket, they're going to give you a bracket. You need to end that bracket at the end of it. So we would end that bracket here. Now, when you push this sine, it's going to start a bracket. Make sure you end it as well. Divide by 5.5 and then hit enter. Alternatively, if you find that a lot of calculator work that's hard, you can work out this answer, store it in your calculator, and then go second sine of that answer, retype it out or hit second answer, and then that will work as well. So be very careful. This is the correct answer, so just make sure you get that it's the 49.588 blah, 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 and then round that to 50 degrees.